Okay, hello again, folks. I was also asked to go through an example where you've got two different strings, because I think some of you are getting a bit confused with how you get the equations of motion. So I picked question 9. I also think question 9 is what really exemplifies this idea that kind of comes through in these questions, that really we assume things are vertical in these questions unless they say that they're horizontal. So there's actually nothing in this question that specifically tells you that the problem is horizontal. So then I guess what I'm saying is the idea is the best thing to do then is assume that it is vertical. So it says an elastic string AB with natural length L and modulus elasticity 2 mg. And then we have another one. So we've got AB and then we've got BC, and they are joined together. So B and C are the same point. And then we've got D at the bottom. And then we've got a particle is hung at D. So this is mg. And then I guess some of this is about understanding the tensions and getting the equations of motion. So there would be a tension here, but with that idea, same as when we had like the rods and the pulleys, we're also going to have that same tension equal and opposite here, and then we would have a tension here, T2. This has been extended, so this is the distance here is like L plus x1, so the natural length plus the extension of that, actually I'm going to call this x2 because I called that tension 2, and this one has a value of lambda of 2 mg, and this one has a value of lambda of 4 mg, and then here we've got its natural length, which is the same, plus its extension. And so you can see from your equations of motion, if you just look at resolving the particle at the point D vertically, so if you just look here at this particle, the only forces on it are tension going up and mg going down. So actually we get that T1 equals mg. So from there we can say that our 4 mg x1 divided by L equals mg. So our mg's cancel, and I get that x1 equals a quarter L. Similarly, if I look then just at the point of contact here at the point BC, so if I resolve like vertically at the point BC, well actually the forces acting here on that part of the system just tell me that T1 is equal to T2. The whole thing is in equilibrium, so that point there must be equal, which again tells me that T2 is just equal to mg. So I can get a similar equation of motion. This time my lambda is 2, so 2 mg x2 over L is equal to mg. Mg's cancel, so I end up with x2 is equal to a half times by my L. Cool. So then the question is actually asking you to find AD. Well, if you think about the whole distance, these were just the extensions. So we've got the natural lengths of both springs plus the extension of x2, which is a half L, plus the other extension, which is a quarter L. So altogether we get 11 over 4 L. I hope that helps. I think the hardest thing here is realizing that it's vertical because it's not specific in the question, and then seeing that actually the tension, even though it's two separate strings, if you look at individual components, because there's no other forces going on, this tension must be the same as the tension going upwards. I hope that helps. Let me know if you've got any problems. Take care. Bye.